There we go. All right, we're going to do a quick primer now on structs, and I am recording this. I've got my iPad shared for our whiteboard, and a struct is really a mini class. What we're going to do at the end of this week in Module 4 is take a struct and convert it into a class, and that conversion actually is practically trivial because of the way a structure syntax is. It models the same syntax of a class. So it's sort of a baby class. The only thing that a struct doesn't have that a class has are going to be both a couple of things. One, the ability to protect data by making things either private, public, or protected. And then the other thing is a struct does not have any methods. You can't create any mini functions that are only available to members of that struct. You can't do that with structs, but you can with classes. So really this whole semester we'll be getting into all of those types of functions. So then just to review structs at least, structs are a way to give us access to holding a lot of data in a small footprint of a data structure. So we remember if we had arrays, remember when we had arrays, an array has to be of the same data type. So if we had an int here, and if we had another array, say that was going to be a string, and then maybe we had another array that was a double, and then finally another array that might be another int for whatever purpose that is. We do remember that we could not store these in a single array because an array's got to be all the same data type. We couldn't make it a two-dimensional array because the two-dimensional array also has to be the same data type. Other languages are a little more forgiving. Python will let you do a lot more flexibility, and Java will let you do jagged arrays that are connected, but they're not the same size. With C++, all of the arrays have to be the same data type, and if we're talking a two-dimensional array, all of those rows have to be the same length. So these are some constraints that we're up against. What a struct is going to do for us, though, is give us that ability to store related data elements. So what that would look like is, let's say that here let's say this is index number 4. Here in index number 4, we have some data elements. Let's say I'm going to just pop some data elements in here. This is a 6, this is a TRW, this is a 4.4, and this is a 20. Well, these data elements are related. These are parallel arrays, and every index contains data across all 4 arrays that are related in some fashion. Well, what a struct is going to do for us is give us the ability to store these disparate data types and store the data in one single convenient place. So now let's remember this, that we had int, string, double, and int. So I'm going to jot that down here, int, string, double, and int. So what we're going for is a single data type, meaning we have got the ability in a single location to store all 4 of these pieces of data. Int, string, double, and another int. Now, and then a struct is going to be our preferred data structure of choice, at least for now, because it's going to become a class at the end of this week. But it's going to let us encapsulate this data. The way that we do that is we first just create we create the struct. And it's sort of like we're creating a user-defined data type. And this data type is one that is going to then contain an abstracted layer of data beneath it of types int, string, double, and int. So what we're actually doing is we're going up a level and creating a user-defined, programmer-defined data type in the form of a struct. So let's take a look at this. If we were to let's see, this int, let's say this was 6 TRW. We had 12.4 and 20. Let's say that these are all data points that would describe, I don't know, how about a part number? Oh, that's kind of boring. Yeah, a part number, we can do that. Where 6 might be the quantity on hand, 20 might be the sales price, 12.4 might be, I don't know, density or number of threads per inch, TRW, a stock number. So you get the idea there. If we're going to create a struct with this that would store this data, well, we would start by defining the struct, and we define the struct up in the global declaration area between the using namespace standard statement and the start of our main function, int main. So right up there in the global declaration area, we would create a struct, and we do that by starting with the reserve keyword struct. And notice that struct has got a capital S on it. Don't make the mistake of putting a lowercase and then hitting yourself over the head for about an hour trying to figure out that error. Capital S on that. After struct, we come up with the data type. I'm going to just call it a part. Then we've got our parentheses. We've got our braces. And then this is a little bit weird too, because we're not used to normally seeing that. Down here, after this closing brace, we do need to put a semicolon there. Don't forget that too. Those two little places where you're guaranteed to pull your hair out trying to figure out what the error was. And then here inside of our struct, that's where we're just going to define the abstracted data elements. So we could have like int quantity, string part number, double density, and then finally int price. Just like that. And knowing that we've got this fully defined now, well, okay, now we can start playing. So what I'm going to do now is shift over and let's actually code this in our IDE, and then we can just start to play. So let's see here. I'm going to get rid of this stuff that we just did for random numbers, and let's go ahead and start a struct here. Oops. And I prefer to put that closing semicolon before you even type anything, because it's just so easy to forget that. And then here we had int quantity. String part number, a double density, and an int price. So there we go. Now I want us to get into the habit of just trying one thing at a time and then getting it to run, just to make sure you don't have any syntax errors that could be easily done. Oh, and what's happening here? Is mine?
It has to be a little s.
Yeah, okay, my IDE is asking for a little less, okay. And there we go, we've got a nice clean run, so we're good here. Now a quick thing on naming, make sure that you name your struct data type there, starting with a capital letter, and that's going to get us into the habit of recognizing a variable versus a struct or a class. A struct or a class will always have a capitalized name, and we want to do that also for our structs. All right, so now this is fine, except we haven't actually created a struct yet. So we can do that by just simply initializing a variable and giving it some, declaring a struct object and then giving it some initialization data. So if I wanted to create an object now, we could say part, and then I'll say this is a tire. And this is then, let's run it. And we're clean, so we know that this is fine. And let's just recognize what's happening here. We have created a variable. except it's an object and not a variable, an object of type part. And it's going to conform to the struct that we've just defined up above. So this declares it, and then what we can do is we can assign initial values to it, or we can just combine it into an initialization list when we declare it, and do both an inline declaration and initialization at the same time. So I'll do a 20, a TRW, a 12.4, and a 20. And then let's get this running. Okay, we're nice and clean, so we're doing good so far. No syntax errors yet. Okay, and then knowing this, we have got one data element of type part. And there it is. Now, you can go and then add some complexity now. I'm going to go back to the iPad and kind of show what that complexity is going to look like. So it's fine to have one data element of that type, but routinely, what we're going to want is either an array or a vector of these structs. So rather than a single data element that's got these 4 elements in it, we said 20, TRW, 12.4, and 6, or whatever. Instead of one data element, well, what if we want to have a vector of these? Or an array of these, an array with a fixed number of them, or a vector with a variable number of these data elements. So that's what program 3 here is really zooming in on, program 2, excuse me, is really zooming in on. No, program 3 is that we want to create some type of storage device for this data. Now, easiest would be an array, but just as easy is a vector. I'm going to go ahead and skip arrays right now because we will want to really focus on a vector here, especially since that's part of our program. All right, so if we now then, instead of creating individual data elements, here I'm going to go ahead and create a vector first. And we've got to remember what data type we're talking about. So we're talking about a vector of type part. And I'll call mine store parts. Now, what we need to do is we got to push some data into this vector. So the most common way of doing that is that you can do either a direct push, or if you're pulling some data from a file, you'll kind of want to amass that data into just a temporary structure, and then we push that structure. So I'll teach that method here. If we wanted to create a temporary structure, let's do that right now. Part temp, we'll do that. And then our temp.quantity, we can set to 15. There's our part number. Density will be something like that. And $40 for that part there. So, all right, we just did some assignments, and let's run this before anything. Oh, what do we got here? Oh, duh. Don't forget to include vector. There we go. All right, good. We've got a nice clean run, so we are on to something here. So the most common thing that we'll do now that we've got this this part object called temp, is now we can push it into the vector. just like that. We're going to push temp into that vector, store parts using the pushback method. So from here, you can see how we can certainly add some complexity, right? We could put this process of retrieving data, quantity, part number, density, price. What if we put those all in an external file, which we know how to read now, and we put that into a loop, and then every time through that loop, we're going to extract 4 values. Let's put those into a temporary struct. And then when we've got that fully populated temporary struct, we just push it into the vector. So that's the challenge of program 3, honestly, it's going to fall into place. It'll be pretty easy. Once you get this concept down, it really is going to fall into place to just wrap this into a very well-crafted loop. And then, make sure that you've got just the syntax all correct. Make sure you've got the data elements lining up and the reads. So, and that's about it for our vector primer 2. So what I'm going to do, I will stop recording, and then let's see if you've got any questions.